All right, we are starting to wrap up our uh, last couple sections on probability. This discussion is going to be about experimental probability and simulation. So how you do a simulation on some data. So to start off, let's look at our definitions. Recall that as the number of trials in an experiment increases, the results will more closely approximate the actual probability. We talked about theoretical probability and experimental, and in the experiment it wasn't always mirroring the theoretical, but the more trials you do, it should. One way to perform a large number of trials is to use simulation. A simulation is a reproduction or representation of events that are likely to occur in the real world. Simulations are especially useful when actual trials would be difficult or impossible to perform. This lesson will concentrate on the use of random number generators to perform these simulations. So in order to perform these random number generators, we're looking for our graphing calculators to come into play quite a bit. So if you don't have a graphing calculator, see if you can get your hands on one. It will definitely be helpful. Okay, so moving ahead, if we looked at a situation and traffic analysts counted the number of motorists per 100 that went in each direction at the intersection. The results are in the table below. So you can see at this specific intersection, they had the possibility of going straight, left, or right. And you can see how many of our 100 went in each direction. Now, our whole process is, instead of sitting there and counting at this intersection, taking our time, etc., we can do what we call a simulation with random number generators. Use a simulation to estimate the probability that 2 or more of 5 motorists in a row will go straight. So, in order to do that, you're thinking, okay, I'm going to have 5 possibilities. What's the probability of going straight? You know, and you can look out of here just at the 100 cars went through the intersection. We've got 30 out of 100. So are we going to say that's 30% chance? Well, we need to estimate the probability that 2 or more and not just use the probabilities. So first piece of information is to take each trial will represent 5 motorists. We're going to generate 5 random numbers. But before we can generate the random numbers, we must assign numbers to the current data. So looking at our data, it makes sense. It was in the order of straight, left, and right. If we add, and you'll notice that's the difference here, if we add this extra box that we did to the right side, these are going to be our random numbers. So when they went straight 30 times, I took the numbers 1 through 30 as general numbers, digits, to represent going straight. Then left is going to be the 31 through 75, which would be the next 45 numbers. From there, 76 to 100 should be the remaining 25. So you can see we've assigned from the original 100 that was an actual experimental data set, we've now assigned random numbers to each of those. And we've done it based on the grouping of straight, left, or right. So now you are supposed to take each of those and make a trial of 1, 2, 3, 4, 5 random numbers. It says generate 5 random numbers. It's not just say you pick one, you pick one, you pick one, you pick one, and I pick one. We need to generate them with a random number generator, something that is proven has the algorithm written in. So to do that, we're going to use our graphing calculator, and we will generate 5 numbers, and we will come up with another piece to this table. So take a good look. Using our graphing calculators, use the math, probability, so find your math key, then arrow over to PRB, which stands for probability, and under the probability, you will look at choice 5, which is RAND, so for random, int for integer, random integer, choice 5. It gives you a parenthesis. In that parenthesis, you want to put your X, Y, ordered pair that represents the range of numbers you are using for this specific data. The range will always change. This one, it was only 100 cars going through the intersection, so we want to go from 1, 100 on our calculator. Okay? Now, the next thing, and I'm going to give you time to do some generating here, the next thing will be, we have these random numbers. If we hit enter, it's going to start generating random numbers from 1 to 100. We need to do 5 because we said we're looking for the probability of 2 out of the 5, and I don't even remember now, turning right maybe. So I'm going to generate by hitting equal 5 numbers. 1, 2, 3, 4, 5. All right, now my 5 are the numbers, and I'll put them here so everybody knows what I'm referring to. My 5 were the numbers 91, 88, 81, 29, and 76. Now obviously if we have a random number generator, yours are going to be different than mine. They're going to be different than your person next to you, etc. So everybody will be generating their own numbers, and we're probably not going to have the same things. However, now based on my numbers, let's match them up. We have, and I'm going to put the turns. That's the whole idea. Straight, left, and right. So I'm going to use S, L, and R in my setup. So a 91 for trial 1 would have been turning right. An 88 would have been turning right. An 81 would have been turning right. A 29 would have been going straight. And a 76 would have been going right. Okay? So I got right, 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 straight, right for my first trial. I will then have to do that again. Don't just hit 5 repeating numbers because they're just going to keep going. You need to go back and go back to math, probability, choice 5, 1, 100, close the parenthesis, and again 5 of them. Right? My second combination was 59, 84, that's a 9, 16, 43, and 19. So again, going to the chart, I've got a left, I've got a right, I've got a straight, I've got a 43 is a left, and a 19 which is a straight. Okay? So I have all those, and I'm going to keep referring to those. From there, I should be able to go back once I do all those. I should be able to go back after 10 trials and find out what was actually the expected result. And remember, the expected result in this case was we were looking for use simulation to estimate the probability that 2 or more of 5 motorists will go straight. It didn't even say go straight in order. You know, it didn't have to be side by side, but go straight in a row. So 2 of the 5 have to go straight. So just looking at the 2 examples we have listed here currently, this would not be a good combination. 2 of the 5 went straight. This would be a yes. So I'm going to keep going after I get all 10 done and count how many out of my 10 had at least 2 going straight in it. Okay? Depending on how it's worded, it might say 2 or more. If it says just go 2 straight, then all I can look for is 2 S's. Anything else wouldn't count. And I could do an easy probability based on that, count how many out of 10, turn that to % if I needed to, and we'd be good to go. We will talk in class a little more about what kind of charts or tables I want to see on your homework because it's going to be similar to these, but that's what we have left to do.